Hello viewers, welcome to part 2 of the video series on basic definition and relationships related to soil mechanics. In this video, we'll be learning the functional relationship between some important properties of the soil. So the first relationship that we'll be learning is between the void ratio E and porosity N of the soil. Now we know that the total volume of a soil specimen is equal to volume of void plus volume of solids. Now from the definition of porosity, it can be written as volume of voids to the total volume. So in place of volume, I'll substitute volume of voids plus volume of solids. Now I'll divide the numerator and the denominator by volume of solids. So it can be written as VV upon VS upon VV plus VS divided by VS. On further simplification, it can be written as VV upon VS upon VV divided by VS plus VS upon VS. So it gets cancelled out, and hence we can say N is equal to E upon 1 plus E, because by definition volume of voids upon volume of solids is the porosity. Similarly, if E is given to us, what will be the value of porosity? So I'll write the definition of E first, which is volume of voids divided by volume of solids. Now, in place of volume of solids, I can write total volume minus volume of voids. Now, I'll divide the numerator and the denominator by total volume V. So, it can be written as VV upon V minus VV upon V. On further simplification, it can be written as VV upon V upon V minus V minus VV upon V. It get cancelled out. And from the definition of porosity, the volume of voids to the total volume ratio is given by N. So therefore, I can write E equal to N upon 1 minus N. So this is the first relationship between the void ratio E and porosity N of a soil. Moving on to the next relationship, that is relationship number 2 between the percentage air voids Na, air content Ac, and porosity N of the soil. Now, the definition of the percentage air voids is volume of air to the total volume. Now, in place of total volume, I can substitute volume of, sorry, I'll divide this both numerator and denominator by volume of void. So hence it can be written as VA upon V divided by V upon VV. On further simplification, I can say VA upon VV equal to VV upon V. So by definition, the ratio of volume of air to volume of voids is nothing but the air content, and the ratio of volume of voids to the total volume is porosity N. So therefore I can say Na is equal to Ac into N. Now we'll move to the next relationship, that will be the relationship between relationship 3, that is between percentage air voids A, void ratio E, and degree of saturation S. Now the definition of the percentage air voids is Na is written as volume of air to the total volume. Now, in place of volume of air, I can write volume of voids minus volume of water, because voids comprises of two things, air and water. So, it will be VV minus VW upon B. Now, from the definition of the degree of saturation, I know S is the ratio of volume of water to the volume of voids. So therefore, I can say volume of water will be equal to S into VV. Let this be equation number 2 and let this be equation number 1. In this equation number 1, in place of VW, I'll substitute S into VV. So therefore, the percentage air voids can be written as VV minus S into VV to the total volume V. Now, from the numerator, volume of voids will be taken as common, and in the bracket, I can write 1 minus S to the total volume V. Now, the ratio of volume of voids to the total volume is the porosity. Hence, the percentage air voids can be written as N into 1 minus S. But we know from relationship number 1, N is equal to E upon 1 plus E. So if I substitute this value in this equation number 3, therefore value of percentage air voids can be written as E into 1 minus S upon 1 plus E. So moving on to the next relationship, that is relationship number 4 between the water content W, void ratio E, specific gravity G, and degree of saturation S. So we know from the definition of the water content, W is equal to mass of water to the mass of solid. Or you can write weight of water to the weight of solids. Now, in place of mass of water, I can write rho W into VW, and in place of mass of solids, I can write rho S into Vs. Now, the density is the ratio of mass upon volume. So, since mass is unknown, it can be found out using rho into volume, that is density into volume. So, using that basic funda, we have written the expression for mass of water and mass of the solid. Also, we know S is equals to volume of water to the volume of voids. So therefore, I can say volume of water equal to S into VV. Also, by definition of specific gravity G, it is the ratio of density of the solids to the density of the water. So therefore, I can say rho S will be equal to G into rho W. So let this be equation number 2, let this be equation number 3, and let this be equation number 1. I'll substitute the value of 2 in place of VW in equation 1 and G into rho W, that is value of equation 3, in place of rho S in equation 1. So therefore, the expression for water content will be rho W into S into VV upon G into rho W into Vs. Rho W and rho W gets cancelled out, and the ratio of volume of voids to the volume of solids is void ratio E. So therefore, I can write W equal to S into E upon G, and on further simplification, I can write that this as W into G equals to S into E. So that was the relationship for between water content, void ratio, specific gravity, and degree of saturation of a soil specimen. So that's all from this video. If you have liked the video, hit the like button, share it with your friends, and subscribe to our YouTube channel for more videos relating to the various topics of civil engineering. Thank you.